This video is dedicated to the channel Colman FE, which means Black Star. The guy is really brainy in spectroscopy. Please log into his channel to find out more. Radio spectroscopy and nuclear processes made easy. Basic tools. One of the basic tools is somebody who's going to take care of the experimenter, and in my particular situation, it is my wife who is taking care not only about me, but about the cat. So we need to be pet from time to time, and eventually we're going to be taking care of our needs, so we could dedicate our life to the science. Of course, we have to eat, but sometimes the first is the cat, and the second is the husband. And then it comes time for the lab. Determination is the most important. Some of you may go for used electron microscope and find out what is the diffusion pump underneath of it and the huge big cable connecting electron gun sitting on the top of electron microscope to the high voltage power supply. Curiosity to see how things behave in a vacuum may lead you to purchase vacuum chamber with the glass bell jar to experience for the first time in your life what is 2 times 10 to minus 7 of the millitorr. Internal structure of the vacuum chamber, you will discover that this thing does have a roughing pump, which would be a vacuum belt driven pump, and the diffusion pump as well. And the diffusion pump doesn't have any moving parts. It only uses an oil that evaporates because it does have a heater at the bottom of it. It goes to a certain height and then being reflected from the metal plates inside that tube goes down, catching up on the molecules of air. That's all. Glass envelope with filament inside, looks like a vacuum tube connected to the vacuum system, and when you light that filament and doesn't blow up, at least you know that you have a right vacuum in it. To measure nuclear processes, you at first need to know what you want to measure. And I found Colman FE 1956 patent of non-radioactive compound creating an electricity for free. And then you think, what tool may likely give you a help? Vector network analyzer will probably not, but quadrant sensor ranger will be good for gamma and neutron radiation, and medical X-ray detector will help you as well. And one might think, what? I don't have an X-ray tube. How come? When you take the coffee to think about it, looking at radioactive glass, there's plenty of glassware there, and thinking about nuclear material that could blow up, at first you gotta make sure that you don't upset your wife too much or get her bored, or maybe she starts to count how much money did you spend already on the lab. So playing a scientist or being a scientist is not an easy task. That is also very much important when you decide to go science. However, I think I'm one of the lucky ones with the full approval of all of the proceedings. But since the harmony is one of the things of nature, I am trying to make potentially nuclear material to not start to decay. Ranger was made for United Nations to investigate the presence of possible nuclear weaponry in Iraq, which happened to be completely false weapon of mass destruction, laughable. But it was a good device and good money spent on it. It does have ability to create a graph and assign the spectral components to the particular radioactive substance. It does have a big library that you see right now in here, and will allow to compare the peak that you have from the screen to the peak that is in the library. It will also immediately recognize, and the right hand side of the screen will show what radioactive material was assigned to the mathematical algorithm that is in the library. Uranium is natural ore that is very much present in nature, and that natural ore was utilized by Russian to create free energy nuclear generator, that's all you see, to provide electricity for, let's say, 100 years. That depends also from the decay time or the half-life of that isotope. Uranium is contained in the glass envelope that is in the middle of the structure, vertically placed, and then you have a coil that has more wires wrapped around with the coil with 3 wires on it, and that coil is connected to the resonance circuit. Now we have inverse and voltage structure, which then is connected to the light bulb. Comparing to the concept of Colman, he used very much similar structure. The only thing is that he used 2 pairs of electromagnets with the metal brackets, actually dispersing the radiation and concentrating radiation on the ends of the tube. So the only difference that I could see between Russians and me is that I experiment with 100% non-radioactive matter based on Colman experiment that may or may not decay, influenced by radio waves, and if it does, that would be a new chapter in physics, as physics says that is impossible. Elements of nuclear spectroscopy would be sodium iodide crystal, very much similar to our kitchen salt, and that one creates visible light explosion of the photons impacting that crystal. That light then goes to photomultiplier tube that is placed next to it, which is actually the visible light amplification device. At the end of it, it may go to the BNC connector and the software, showing you the graph of what contents is there, or it may go to the phosphor screen, which then will create inverse image of that radiation, and that could go to the camera. At the BNC connector connected to the TV monitor, you would be able to see an image of it. That is very much similar to the medical imaging, including X-ray imaging. That particular gamma spectroscopy device has 2 photomultipliers, one on the top and the bottom, and I show Colman tube in the middle, and the photomultipliers on the top and the bottom. The green is the sodium iodide crystal, the orange is photomultiplier, and the blue is power supply. Or blue could be a phosphor screen, and then on the top of that you could have a regular CCTV camera that is attached by BNC connector to the regular TV monitor, and you could see the image of radiation if there is any. So the whole basic safety of my scientific investigation is that I'm dealing with something that should not, based on official physics, give any results. Few words about photomultipliers. Photomultipliers are the tubes that have a number of electrodes, one anode, one cathode, and dianodes, which are in between. And this particular device is another gamma imager. This one is made not to give the graph, but give you the physical image like from the camera. It does have in front of it disk, that the disk is a collimator. A collimator actually is a honeycomb at the thickness about half of an inch or less, with the parallel holes in it, dozens of them, and when the gamma ray gets into it, it will make them parallel and direct them to the crystal. I'm explaining right now from broken photomultiplier example how that structure looks like. You see the electrons coming to the hole, and then that's what I'm showing, that they are dianodes. The difference in voltage is about 100 volts, so a very small amount of photons comes to the photomultiplier exchange, the stream of electrons going to the particular dianodes, and then next to it, which everyone amplifies those electrons thousands of times. At the end, you have a BNC connector, and the signal goes further. That what I'm holding is a collimator, and I'm giving an example of something that is a crystal sodium iodide, but it's from different device, just to show how it works. Gamma spectroscopy imaging device comes with 2 circuits with 5 collimators all together, very much typical honey bean structure, used to straight out the gamma radiation going to the crystal of the photomultiplier. When I took out the device, I find out that orange wire is a fiber optic, and the other one is just 2 wires for 12 volts. The high voltage power supply for photomultiplier is built into the device. Some of you very much experience how to go from fiber optic to USB. I would appreciate if you give me some advice in this area. But I'm digging in all of those fascinating things around me. I'm trying to find out, while drinking coffee, what is the real beauty of the nature, whether this is discovery of something that is unknown or just the ropes of my life. The place where you see the specimen is a place where the Colman tube will be placed. The activity is dedicated to do not deal with living organisms. All of that was pretty much humanitarian because the specimen was still alive. For some of you who are very curious about gamma spectroscopy, if you imagine that the Colman tube is on the top of it, and let's say for a moment the Colman tube will react, then the gamma ray will go through the collimator that is on the top of it, and then will go to PMT, which is photomultiplier, and then it will go to the location grid, and the location grid is nothing less or more but the series of photodiodes in the grid, like pixels in the screen of your TV. Understand how the structure works is by looking at the cross-sectional of the device. On the top, collimator, then detector, which is the crystal, that is in the heavy walls of lead, housing the big place in between is photomultiplier, and then it's a location grid, phosphor screen, pixels made out of the photodiodes. Each one will read intensity of the light. The overall signal goes to the electronics, and through the fiber optic goes out to the USB. Amazing and very good technology, although discontinued. Upper picture, 12-volt DC box, right, one fiber optic and 12-volt wire, and I support. Spectroscopy or high performance liquid chromatography. The glass is not a glass, it's a crystal, and you have a tubing inside where you pour the liquid. The other cell has a tube, and that glass tube has inside the crystal that is abandoned. There are inlets and outlets with micro tubing into it, and that allows liquid to flow. So the assumption is that the liquid must be radioactive. You have two photomultipliers, one on the left, one on the right, and you have a space on it. The dark piece of metal is the lead base neck that will go to the shielding. There is an O-ring made of the rubber. When you squeeze those two photomultipliers together, it does not allow to any light to go in. The high voltage is delivered from each side of that housing to the photomultiplier tube, and the BNC connector will allow the signal goes out. The basic structure is that when you have a signal from both of the photomultipliers that is the same, then you have a clear signal with no interference. When there is a signal that does not appear on one but it appears on the second one of the photomultipliers, there is a Compton noise. Some of them call it cosmic noise. Whatever the origin of the noise is not what you want to see. Manufacturers use stack of photomultipliers, 6 in one stack, 6 in the second one, and then each one of the photomultipliers has its own power supply and preamplifier. That is done for the reason when they have a pallet with the micro drop cells, each one supposed to be independently screened. In the light seal enclosure, then there is no need for screwing the screws around the cell. It is simply flow of those cartridges, and the result is displayed on the screen. Low energy nuclear reactor by Andrea Rossi, the Italian who had a problem with the law because of whatever he did to the Italian government, shows up with his low energy nuclear reactor, and he uses definitely the devices that allow to detect beta and gamma and X-ray radiation. What he uses hydrogen gas and nickel, just a little bit of the nickel decaying to copper. He also uses secret additive. That secret additive, I assume, is a cobalt, which make that device very much similar to Colman device from 1956, and therefore it will make a grip for him to obtain necessary patents, or even though that he's got one just to reinforce their power. HPLC system is a perfect one to find out what's going on in a compound if one decides to make this kind of experiment. And since I'm going very deep into this area, I believe I would also be able to scrutinize that patent, as energy is free for everybody and should be of equal access at no charge.